Welcome everyone to the June meeting for Integration Down Under. Just got a couple of slides to go through before we start the presentation. So just again, our organizers, Martin, Dan, Renee, Wagner, and myself. Our topic tonight is, our presenter is Mandar, and the how to build serverless helmet detection system using custom vision, Azure Functions, Event Grid, and Logic Apps. So a lot of the integration technologies there. So without any further ado, let's go ahead and get started.
All right. Thanks, Bill.
Okay.
I'm grateful for the opportunity to speak in this forum today. Hello, everyone. Good evening to all. Thanks for attending today's session. The title for today's session is how to build a serverless helmet detection system using custom vision, Azure Functions, Event Grid, and Logic Apps. That's a long title. But my name is Mandar Dharmadhikari, and I'm connected today from the beautiful city of Churches, Adelaide. So let's start. Since this is my first time, I'll just quickly tell you guys about myself. I'm Mandar. I'm a BizTalk developer and administrator for Mphasis Australia Private Limited. I'm an integration and AI enthusiast, and I particularly like to explore Microsoft Azure offerings around them in my free time. Apart from that, I am a TechNet Wiki Ninja and author. I have done some reviews for Azure related packet video courses, and when I'm not working or learning new techniques in Azure, I'm a diehard Metallica and Game of Thrones fan. Below is my info, which I will share again later on in case anyone wants to connect with me. So before we discuss the agenda for today, I would like to say that there are various components that were used in this fun project. Given the time constraint that we have, I will highlight the basic of these offerings. There are many fantastic presentations here on Integration Down Under channel, YouTube channel, which you guys can later explore if you want to learn about these concepts in more depth. So having said that, the takeaways from this session are we'll touch upon what Azure Custom Vision Service is. We'll take a look at the Azure Component Visions, Computer Vision Service. Take a short look at what Logic Apps are, what Azure Functions are, what are the event grids and how we can use them. Then I'll quickly discuss the system architecture, how these components fit together to create the helmet detection system. And then I'll do a quick code peek and demo and show you the actual working of the system. And then I'll briefly discuss why we should use Application Insight to monitor the system. We'll then discuss some best practices and my experiences in developing this, and I'll point you to some further reading materials. So I've recently started experimenting with the Custom Vision Service, which comes as a part of the suite of the cognitive services provided by Microsoft and which are hosted on Azure. Cognitive services offer several specific AI or machine learning tasks which are provided as service via an API that we can generally integrate into web, mobile, or our desktop applications, because they basically work with JSON-based REST calls over an HTTP endpoint. Or in many cases, Microsoft has also released a lot of SDKs to make our life a lot easier while developing these things. So the Custom Vision Service has following characteristics. It allows us to build, deploy, and improve our custom image classifiers. So the custom image classifiers basically allow us to tag different areas in our images and allows us to maintain it in our own way. So custom vision allows us to apply labels to the images according to our requirements. Custom Vision Service supports two models, that's object detection and classification. So we can train our project to do either of the tasks. Azure Custom Vision Service comes with a lot of out-of-the-box machine learning algorithms that are well suited for different scenarios. Like we can have a algorithm which specifically deals with, let's say, helmet detection. Then there is one which deals with pictures in nature. So there are a lot of algorithms which are closely aligned to certain domains. We just need to find the domain in which we want to train our app. Then we have the ability to do SDK based or in portal development for our models. The most beautiful thing that I find for Azure Custom Vision Service is that it allows us to export our trained model and run it on the device closer to our data as a containerized app. So that's a plus point that we have with Azure Custom Vision Service. It can be deployed to IoT Edge. A typical development cycle for Azure Custom Vision Service project is we upload the images to the portal. Either we do it directly on the portal, or we can do it using a SDK. Once that is done, we need to tag the images to determine the objects that we want our model to detect at a later point of time. So a general rule of thumb here is that to detect a particular tag, we should upload at least 50 images for a model to work sufficiently accurate. Once the images are tagged, what we do is we align it to one of the model that is available to us in the portal, and we train the model. Once the training is done, we can test it over HTTP endpoint, and we then repeat the entire process till we get the granularity of the response that we want from the model. So the payment for the Azure Custom Vision Service works on a pay-as-you-go model, where the cost depends upon the usage, and with generous free tiers that are provided by Microsoft for this custom vision service, we can do a lot of experimentations and testing, and even we can run small loads using free tiers even in the production. I'm not sure if that is available for support, but that's a different thing. Thus, in a nutshell, custom vision allows us to manage our own model for detection or classification of certain objects in our images, while it still abstracts the machine learning part and algorithms, allowing us the ability to develop the products faster and do faster deployments. Let's take a look at what Azure Computer Vision Service is. So Azure Computer Vision is another cognitive service offered by Microsoft, which caters specifically to image analysis. A major difference between the computer vision and custom vision service is that computer vision is trained and managed by Microsoft using some predefined algorithms, while custom vision grants us more freedom to tag and train a model based on our specific domain. Some salient features for Azure Computer Vision Service are it allows us to analyze image using pre-existing algorithms. These algorithms are again abstracted from us. We only give the API the image either in a byte array or a URL form, and that's it. We get rich information-rich JSON back. So it's really easy for us to analyze the images while still not worrying about what algorithm is applied in the back. Azure Computer Vision Service allows us to do optical character recognition, which in turns allows us to extract out handwritten as well as printed text from our images. Another fun thing is it allows us to recognize famous personalities, places, landmarks, etc. It allows us to generate thumbnails. There are many more fun things which computer vision service can do, but they are basically classified into these 4 main categories. I would urge you, if you are interested, to explore the Microsoft documentation on this. It is really extensive and fantastic stuff out there. So computer vision supports REST-based calls, wherein we can pass the images to the REST endpoint using as the byte array or the URL to the image. Or in case if we are inclined to use SDKs, we have SDKs available for ASP.NET and Python. So it really makes the development of the apps really simple and easy. Another great thing with Azure Computer Vision Service is that it can be deployed. It can be used in Azure. Apps can be deployed to Azure or can be run as containerized app closer to our data. So that's again a benefit of using Azure Computer Vision Service. And day by day, it is getting more and more accurate to analyze the images. Next is, again, I would like to point out that the free tier that we have for Azure Computer Vision Service provides, I guess, 3,000 or 4,000 API calls per month. That is still sufficient for us to do a lot of experimentation and testing of our own before actually selecting a pricing tier for our production apps. So moving on, what are logic apps? So logic apps are discussed in detail in one of the other presentations done by Azure MVP Wagner, where he has explored logic apps and Microsoft Flow. I would urge you to watch that session, as it really provides great insights into logic app and Flow and when we should choose which technology and why. So at a high level, logic apps are part of the Azure integration services provided by Microsoft. They reside at the heart of integration as a platform, integration platform as a service offering of Microsoft. Logic apps are completely serverless, as the logic app runtime engine is completely accepted from us developers, and it is maintained by Microsoft internally. This makes logic apps a true platform as a service offering. Logic app allows us to automate workflows and orchestrate business processes. These integrations can range from simple data integrations to enterprise to B2B and even application integrations. Logic apps work with designer first approach, wherein we can develop the logic apps using Visual Studio or even using the portal. If we have any BizTalk developers here, it's kind of similar to the orchestration designer or a pipeline designer that we have in BizTalk. Not exactly the same, but visually it's the same concept. Logic apps have a lot of out-of-the-box connector, which enable us to do lightweight integrations. So why use logic apps? So from a business perspective, they provide us serverless integration. We don't really need to worry about the backend engine or any details about how the engine works. We just need to develop our code and deploy it, and rest of it is managed by the Microsoft. It allows us to connect legacy systems to new cutting-edge systems, thus marrying the old and the new systems in an effective way. When logic apps are coupled with BizTalk, the integrations that we can create are really powerful and robust. Since logic apps require very less, no or very less code, it reduces the time required to release a particular API. Integration platform as a service provides reduced operational costs because we are not worried about OS patching, vulnerability management, and stuff like that, which normally comes when we are using infrastructure of our own. And the greatest advantage with logic apps is the micro billing. We only pay for what we use, and the billing is done based upon the execution of actions. From a developer's perspective, Azure logic apps are easy to design using Portal. Well, not so easy using Visual Studio. Once we get a hang of it, they are easy to deploy using the Azure resource management templates. This allows us to, it gives us the ability to set up continuous integration and deployment using Azure DevOps. We have around 300 out of the box connectors for API consumption. If we don't find any connectors that serve our purpose, we also have the ability to create custom connectors, and it's really easy. Next, I want to cover is what are Azure Functions. So Azure Functions present another side of the story of running serverless workloads. Azure Functions are serverless compute service, which are run on the platform completely abstracted from the developers, thus making them truly serverless in nature. Azure Functions are just small pieces of code, small methods, if you will, if you relate it to through a procedural programming perspective. These small pieces of code run on the Azure Functions runtime platform. Azure Functions have a plethora of triggers and bindings. Example would be bindings for event grid, HTTP, webhook, timers, Azure Blob, queue bindings, SendGrid, Cosmos DB, just to name a few, and there are a lot more. Another salient feature of Azure Function is that they are multilingual. They support development in multiple languages, C#, JavaScript, PowerShell, even to F#. Just we need to pick up what language we are comfortable with. Azure Functions are suitable for people from development background, as they offer the freedom to the authors to author the code according to the need, which also gives us the gives the developer ability to develop and debug functions locally from before deploying them to Azure, which sadly is not possible with Logic Apps. So Logic Apps, we have to test them in Azure. Azure Functions can be deployed as containerized Docker apps, which I think is another great features. So recently I heard an announcement which said that Azure Functions now support .NET Core-based dependency injection, which basically means no more static functions. So when I read this and successfully implemented dependency injection in non-static Azure Functions, my reaction was like this. I was really happy. So EI to no more static functions. So moving on, let's quickly cover up what Azure Event Grid is. So Azure Event Grid is a fully Microsoft managed routing service offering of Azure, which delivers event notification using lightweight HTTP call. The Azure Event Grid is baked in Azure, and by default, many Azure activities that we perform may trigger some kind of event which can be captured through the event grid. Simplest example for an event would be when a blob is created or deleted, or when a resource is deleted, etc. There are a lot of events available under different namespaces for us to react to. This lightweight notification allows us to develop event-driven solutions which work on the publish-subscribe model. Again, if we have BizTalk developers here, they can relate to this PubSub model because BizTalk basically works using this concept. What it does is it promotes a very loosely coupled architecture style, which I really like to implement and which I think is efficient. A great feature of Event Grid is that it supports the publication of the built-in Azure events as well as our own custom events, which can be published to custom Event Grid topics. Azure supports the Event Grid schema, which is the default JSON schema in which the Azure events are published, or we can use the open source cloud event schema to publish the custom events. It also allows us the ability to put filters on the subscribers so that subscribers relate and react only to certain events out of what we have published. So Azure Event Grid has very high throughput and it's really resilient, and it allows us to react to events in almost real time. It is very cheap, and the billing model is pay per event. So if we take a look at this image on the right hand side, it clearly shows us the event sources that are available. So blob storage, resource group, Azure subscriptions, and many other things generate events which are then published onto the event grid. And even at the bottom, if we see, we have custom events that can be put onto event grid. And on the right hand side, we have the event handlers, which can react to the events that are put on the event grid. So that can be functions, that can be logic apps, and event hubs, storage queues, many other stuff like hybrid connections and webhooks. Even we can use them in Azure automation. So that covers the basics of the components that were used in the system. So this image shows the system architecture. Now, before we discuss the architecture, since this system uses Azure Custom Vision, which deals with images, this system does not cater to the video feed, which is uploaded through the device. So the idea behind the system is that the camera captures the full frontal image of a driver driving a motorcycle or a two-wheeler. With that image should probably contain the number plate and the face of the driver, so that the system can recognize whether the driver is wearing a helmet or not. That image is then uploaded to a blob storage, to a particular container. And once that image is uploaded, it triggers a blob created event onto the event grid. Then we have a Azure function called as detect helmet, which reacts to this particular quote blob created event unquote. And once we get the URL for the blob that was uploaded to the container, this function sends that particular image URL to Azure Custom Vision project that we have developed for this architecture. The custom vision endpoint then analyzes the image and detects whether a helmet is detected for the driver or not, and generates a JSON response, which I'll show you in a little bit, which says whether we have detected a helmet or not. So based upon that result is, so if we detect a helmet, it's all good, we don't do anything. If a helmet is not detected, it pushes the event, a custom event that we create. Now I've used the event grid schema structure to create my custom event. So it publishes a custom event which says that the helmet is not detected. Then there is a logic app which sits at the top, which subscribes to that event. And once it gets the URL for the blob that was uploaded here, it sends it to a function called as extract number plate, which internally calls Azure Computer Vision Service, and the Computer Vision Service extracts the number plate. Now, once the number plate is successfully extracted, it again gives a call to another function, which goes to the DMV database. Here it can be SQL. In my case, I have used a table API. So it gets the driver details and then creates a mail body and sends out a notification to a driver saying that you were detected without riding a bike without wearing a helmet. An infraction has been recorded. Now, if the record against the driver is not found, or if we are not able to extract a number plate, or even if we fail to detect the helmet, whether we had helmet or not, no helmet. So in all these conditions of uncertainty, or even in case of exceptions, what they do is, what each of the functions or each component do is they publish out a custom event which says that we need a manual intervention here. That is again published to a custom event grid topic, and there is another logic app which is listening for that event. So once it gets that event, what it does is simply gets the blob from the container where the image was uploaded and moves it to another container, which basically is used for manual intervention. So that blob is deleted from the input container and moved to manual container. And another step that can be done is we can create probably a ticket in our ticketing system. That is something that I have not done yet, but that's the entire architecture for the system. So now what I'm going to do is I'm going to quickly move to custom vision project, and I'll show you now. The important point is, since I cannot show you the real life images of driver and their numbers, what I've done is I've grabbed few free images from Google, and I've trained my app just to demo it here today. So what we have here is I have uploaded a lot of images here in the project. And what I've done is I have tagged each of the images to detect a particular, whether a particular image contains a helmet or not. So for example, if we select this helmet, this image, it shows that I have tagged this area and this area, and I've said that this shows me helmet. So I have done it with more than 50 images, as which is prescribed in the documentation. And for images that don't contain helmet, I have around 28 images. That's the only number I could find. So sorry about that. Yep. So what I've done is, if we select, let's say, this image, all it does is says that this particular area denotes a no helmet. So that way, as and when we upload many images and we tag helmet and no helmet and then train our app, it will make our app more and more intelligent. So once we finish the tagging of images, what we do is we just click on train. Now I have just used fast training, which trains the app very quickly. If we want to go for advanced training, that incurs extra billing, so I have not done that. So I have used fast training. And once that is done, we can view the for app. So once the application is trained and published, it shows us the precision of the model that we have deployed. For example, here, if I have a probability threshold of 50%, it gives me the precision that my model can detect a correct tag 93.3% of the times. The times it can recall what the previous tag was detected was 87.5%, and then there is this mean average precision, which tells us the overall object detector performance across all tags. So it's 100%. So this is what I have achieved using around 70 or 80 images in total. But think about it, if we have real-time data, if we are developing this app for the government, and if we have thousands of images, our model will be really powerful. And all it takes is probably a few hours of development if we do it through SDK, or probably some more time if we do it through portal. And if we want to do a quick test, we can test it in the browser. So what I'm going to do is I'm going to browse a local file. Presentations. Yeah. Okay. Integration down there. Yeah. So this is I'm going to use. I'm going to use this image to test our flow. So this says that my model has detected that this particular person is not wearing a helmet, and the probability of that is 85.7%. So we can develop our code in such a way that our Azure functions only publish that no helmet is detected on our image if we get a certain probability in the result from the custom vision. For example, let's say my function puts out a no helmet event when right now it's if the probability is greater than 80%. So that's how we can control the results in our Azure function. So once that's done, let's move to Azure portal. But before we do that, let me just quickly walk you guys through a fun part. That's setting up the dependency injection for Azure functions. So what we need to do is we need to add a startup class to our functions project. And basically this function project implements a class or inherits a class called as function startup, which if we see here from metadata, basically implements the iWebJob startup interface. So in our startup class, we just configure what instances that we want to inject when the function starts. So as a best practice, I have added singleton instances of computer vision client, custom vision prediction client, and a cloud table client, because these connections are going to be pretty much same throughout the code. So I've added them as singleton. Then the helpers that I have for publishing events to the event grid or analyzing what result were sent by computer vision or custom vision, I have added them as either singleton or transient, and that's it. So if we check the one function, for example, all I have to do is then create a public parameterized constructor and inject my dependencies, define my dependencies here. So that's it. When the function starts, it now injects the registered instances into the instance of this class. So when it is newing up the instance for this particular class, and if you can observe, there is no more static uh, qualifier here for my run method. So it's a tested code now. It works fairly reliably on Azure now. So that's what I wanted to show you from a code perspective. Now, if we move to Azure portal, let me go to my resource group. So what I have here is one registration for computer vision, which has generated the keys for a free tier for computer vision. These keys I can use in my function app. Then custom vision, when I register, generates two registrations, one for custom vision API and one for custom vision API prediction. So prediction is one which we are going to use to query the endpoint, while custom vision API just allows us to create a project after we log in using the directory in which, or rather the subscription in which we have registered the Azure custom vision. Then I have application insight here, which monitor my functions app. My functions app, it's called as helmet detection function app. Then again, it's a free tier function app. This storage account stores the logs for the function, and it doesn't store anything other than that. This is a custom topic that I have created, wherein I put out my custom events. So there are two subscriptions here which react to the custom events that I have published. So both of them are logic apps. So one logic app is subscribing to an event which has this particular prefix in its subject line. So when I have not detect, or rather the custom vision has not detected any helmets, so it puts out an event which has a subject line which contains this, and one Azure logic app reacts to that particular event and starts the flow. While if we encounter any exceptions, or our system is not able to detect or come to a proper conclusion where there is a helmet or not, or if there are any exceptions, what does individual components in the system do is that they publish an event which contain a subject like this. So there is one logic app which reacts to this event and then moves the blob from one container to another. And that being said, I have used SendGrid to send out email notifications. This is my storage account where the blob images are uploaded. Images are uploaded into the input container, and right now there are no images in there, and manual container is used to house images which our system failed to process. If we check the events for the storage account, it has a subscription for function, and what it does is it reacts, or rather the function reacts to this event type microsoft.storage.blob created, and the function only reacts to the event which contains a filter which says that blob was created in an input container. So what it allows us to do is it allows us to house the input container as well as the manual container in the same Azure uh, blob storage account. So by putting this prefix filter, we only react to the images that are uploaded to the input container. So moving on, if this is my function app, and let's take a look at the different functions that I have here. It's taking some time. Okay, so right now the app is in read-only mode because I have deployed it using my Visual Studio. Now there are different functions here which tend to different aspects of the system. So this detect helmets function is the parent function which is listening to the events that are put out by the after the image is uploaded to the input container in the storage account. So what this function does is this function extracts the URL, goes to custom vision, gets the result or the analysis for the image that we have sent, detects whether there is a helmet or no helmet, or if manual intervention is required, puts out the event to the custom event grid topic, and that's it. It finishes its processing. If we have not detected any helmet, then following functions come into play. So extract number plate function, what it does is it gets the URL for the blob, sends it to the computer vision service, tries to extract the number plate. If extracted, good. If failed, it puts out an event to start the manual intervention process. So if the number plate is extracted successfully, then this function is invoked, which this function is called as get driver details. So what this function does is it has only one task. It goes to the uh, table storage and gets the details about the driver against the number that was detected. If it does not find any details, it again initiates the manual intervention flow. Else, it uh, gets the detail and it is ready to pass on the control to another function. So once the driver details function is successful, it then gives a call to a notify driver and record infraction function, which basically creates an email body and sends out a notification using SendGrid and records the infraction for that particular driver. And we have a function called as publish event to custom topic, which is used by logic apps to push manual intervention events in case of failures in logic apps run. Then there is a function called as log to application insight, through which I am sending the logic app events to application insight so that we have all the logging that we want in one place. So that's the overall list of functions that do different tasks. Now the extract number plate, get driver details, notify driver and record infraction functions need to be chained because the execution of the later depends upon the result of the earlier. So either we have two options: either to do it using durable Azure functions or to use logic apps to manage the flow of the moment. So what I've done is I've used logic apps here. So let's take a look at the logic app. So what this logic app does is it basically Yeah, it basically is listening to the custom event grid topic, and it is listening for this no helmet, or rather the event which has this prefix in its subject. Once it gets the event, it's setting up a status variable to succeed it. This is used for logging at a later point of time. Then what we do is we call the extract number plate function here using the call Azure function action. We pass in the detail like the body that we received in the custom or over the custom event grid. Then we pass in the correlation ID and the blob name for uh, setting up structured logging at a later point of time. So if we get a successful response from extract number plate, we then call the get driver details, which if successful calls notify driver and record infraction. So if it fails, we call an event which pushes out the event that we received to Azure function, and which in turn pushes it to a custom event grid topic. And at the end, if there is a failure, the status is set as failed. And now if the get extract number plate function fails, what we do is we straight away call the publish event to custom event topic function in our function app and set the variable status to failed. Then at the last, we call the log to application insights function just to pass on the state of our logic app processing. So we pass in the blob name, correlation ID, event description, event ID, log messages, and the status, whether it was successful or not. So in this way, the logic app manages the state and movement of the flow. And there is one more logic app, which is the manage manual process workflow, which basically is again reacting to the event which has this particular prefix in it. It says we require a manual intervention, and again is listening to the custom topic that we have. So what it does is it copies the blob from the input container to the manual container. So what it is doing is just setting up the destination path, and it overrides if it finds the same blob there. Then what we do is we delete the blob from the old container and log application, or send the log to the log application insights function, stating the status is succeeded if this particular uh, action is succeeded, or if it is skipped, then this is executed. So that's it. That's how the entire system works. Now, before I show you a demo, let me just quickly get to the application insights page. Yeah. So now what I'm going to do is I'm going to show you a quick working of the system. So what I have here is my Azure Storage Explorer. This is my DMV data table, which is a simple table with 3 rows. So what I'm going to do is I'm going to use this particular entry, and it stores the details like the number that is registered and the name of the person it's registered to and the email ID. In real life, there can be a lot of fields to this. So what I'm going to do is I'm going to go to my input container, and let me just delete this. Clean up the system. Okay. Right. So what I'm going to do now is I'm going to upload an image. So let me just create a new GUID for this. I'm going to rename this to the new GUID. Now this is the image that I'm going to upload. Now this is a side view of the number plate, but it still does the thing that we want to do. So we just drag this, upload it to the input container. So it's there. Now let me open up my inbox, and hopefully I'll get a mail here soon in next few seconds. Yeah. So I got a mail from DMV, and it says that, "Dear Jon Snow, our monitoring systems have captured an image of you driving your two-wheeler with registration plates this without a helmet, and an infraction has been recorded." And if you see, it also has infraction ID which the user can quote and gives the user a image of them captured driving without a helmet. That's a happy flow in which we get the uh, mail. Now I'll try to simulate a flow where one of the steps failed. So this image is fairly good image, but the problem is that computer vision fails to extract this particular text from the image. So in such case, what we want to happen is that a manual intervention flow should kick in. So let me just create a new bit again, copy it. And I'm going to upload it to my input blob, input container. And once it's done, now let's wait for a second. And since it's a negative scenario, what it will do is it will move this particular blob out from here and move it to the manual intervention. So hopefully, let's refresh it. Yeah, the blob is gone, and it should appear here in the manual flow. So that's for the demo. And let's move back to the slides. Now the important thing that I wanted to cover here was why we should use application insight. So as we know, logging is an important part of any solution, and as it helps us to debug any issues that we have in any environment. Especially logging proves to be a lifesaver in our production environment when something goes wrong. Now, since this solution mostly utilizes Azure Functions to do disparate tasks, application insight becomes a mandatory tool to monitor the log, as that is the only option we get to monitor Azure Functions. So application insight, what it does is it allows us to view important health related metrics of the application. Examples would be the average processing time, failure rates, dependency failures, response times, etc. Furthermore, application insights allow us to view the app and its dependency call in a nice application map, which I really like. Gives a holistic view of the system. It now also supports real-time telemetry, wherein if we want to monitor what's going on, we can turn on the real-time telemetry and observe the movement of the logs as the system processes certain files. Then we just move back to code once. Now, if we see that for this particular method, which is decorated with this function name attribute, we see that we are injecting an instance of iLogger in this particular method. So what it does is it allows us to, or rather the iLogger allows us to set up structured logging for our functions. So I believe this is a really nice features, and it definitely proves to be a lifesaver, as it is easy to lose track of what is happening if you don't have a type logging in place for loosely coupled architectures. So if we don't have a structured and a correlated logging, which can allow us to correlate different events from different functions, we will be lost. So that's important that we set up a structured and correlated logging in our uh, application. So once Example for that would be I have here in my constants class logging template. So this logging template gives me event description, the processing workflow which process at a particular step. It is correlated using correlation ID. It logs the blob name, the status of that particular step, and we can log the log messages. My processing workflow are the names of the functions. For example, detect helmet, extract number plate, manage manual workflow, logic app, manage notification workflow, logic app. And for each event, I have come up with the different event IDs, which show me what happened at uh, after looking at them, I get a high level idea of what happened and when it happened. So, and I also have a status which says started, succeeded, failed, or processing. Now, I'd like to really give a big shout out to uh, Azure MVP Paco because he has written a really nice blog post on how to set up structured logging. So I would urge you to really give it a read. So if I want to show you how the structured logging works, what I'm going to do is I'm going to go to logs, and I'm going to execute a query here. So let it populate a history. So I have this query. What I'm going to do is, let's say I want to find why this particular image processing failed. So I'm going to execute a query based upon the blob name. And all I'm going to do is copy the name here and execute the query. Sometimes it takes time for the logs to appear because they are synchronous. But if we observe this, we can see how nicely the structured logging makes it for us. For example, I can see the level of the logging, the timestamp, the event ID that happened, the event description, the workflow that processed that particular event, the correlation ID, and the name of the blob, what the status of that particular step was, and the log message that was written against it. For example, this one says that the event ID is 1001, which say occurred in the processing workflow detect helmet. The event description is that helmet detection workflow started. Log message started detecting workflow. It says no, then it says no helmet detected. We have the event ID for that, and it says successfully published it. And if we see at the end, there are two events where one says, okay, so here it says failed to extract a number plate. So it was a faulty scenario. So what it did is uh, it pushed the event to a custom event grid topic, and or the logic app which manages the notifications, sending of the notifications, registered a failed status saying that no, yeah, that's all it said. It failed because we got information that it failed to extract the number plate. And after that, the other logic app, which was moving the container blobs from one container to another, registered an event called as blob copied to manual container. And it says that the workflow which processed it was manage manual process workflow logic app. And it finished the workflow. So you can see if how a structured logging can help us in analyzing what went wrong. Another fun thing with the application insights is the application map, as I said. So it lays out a nice connectivity map for me, and it gives me details of how many calls that were made to what particular uh, artifact and how much time it took. So this is a nice way to view it. And another one is the live metrics stream. So live metrics stream allows us. So what I'm going to do is I'm going to publish one more image just to show you how the live image stream works. Okay. That's it. Oh, I uploaded it to wrong folder. Sorry about that. Load conflict, do not apply. Right. Okay. Okay, so the blob is here. Now let's go to our sample telemetry, and you can see that it shows us the details in real time, the incoming request, what we are processing, and sometimes it can help us to identify any issues, because if anything goes wrong, it pops up here and pops up here in, I guess, red mark, so that we can analyze it almost in real time. So that's it for the application insights demo. I'll move back to the presentation. Now, some best practices and some lessons that I've learned while building this is that add at least 50 images per tag to better train the object detection model in custom vision service. Probably this one is a good one that says use static HTTP client with Azure Functions so that you don't run out of connections. Use single instances of API calls, example, custom vision, computer vision clients if you're making call to document DB, etc. So register them as singletons. This is, I can't stress the importance of this anymore. Add structured and correlated logging in Azure Functions, because that's a lifesaver. I started developing this without setting up a structured logging, and I was completely in dark when something went wrong, and it took me some time to debug what is going on. So always implement structured and correlated logging in loosely coupled Azure Functions. And another interesting thing that I've learned is when we use a logic app with the event grid trigger, if we disable it and we enable it again, it registers a new subscription on the event grid, and it doesn't somehow remove the old registered subscription. So when particularly sometimes when the blob is uploaded, the logic app fires twice. So that's something we should uh, remember while developing logic apps with event grid. Further reading, so the one-stop shop to start reading about these features is MSDN documentation. There are landing pages for each of the services that were offered, and once you are comfortable with the basic concepts, probably would be a good time to revisit integration down under YouTube channel, where we have a lot of great presentations on these individual topics. So that's all, folks, and that's all from my side. Thank you.
Thank you very much, Mandar. We do have one question.
Sure.
Let me just share my screen now real quick. So that should share my screen. We had, let me just bring that participants up. Sendevish, I'm going to enable your microphone so you can ask that question you posted earlier in the chat. I've enabled your mic. You just need to unmute it. Okay.
Hello, can you hear me, guys?
Yep, we can.
Yep.
So thank you to provide such good information. It will really help me and open my door towards machine learning and all this stuff. So let me introduce myself. My name is Sadev. I'm from India, and I have very good experience of the logic app and other stuffs which are mainly used with integration part. So I have one question. Is there any limitation have you faced regarding logic app? Like if you send over 5 MB or more than 100 MB file into any connector and it will got failed, kind of any kind of situation have you faced during this project development?
Well, not really, because the logic apps and functions are working with event grid. So what event grid does is it just sends the metadata, and the metadata basically contains a URL to the blob storage. So if you so it's not really passing the entire image through the logic app or even the Azure function. So what it does is it just passes a reference to the blob through a URL, and whatever functions that we are using, it just sends that URL to the processing machine learning API. So there is no passing of very big messages either in Azure functions or logic apps. I believe it's just few KBs.
Okay. Okay. So, Mandar, I have yeah. Sorry, go ahead.
The other thing to take in consideration on that case is that the message, when you're starting to pick up from the blob storage, if you needed to process that inside the logic app, is going to be the chunked.
Yeah.
That's enabled automatically, and that's the reason why Mandar is saying there is no real, at least on that particular scenario, no real limitation on that.
Yep. So one of the things we might do is put together someone to do a session on like the current state of logic apps. I know that they've introduced the ISE, and they've also updated a few of the adapters to handle bigger amounts of data. So we might see if in the coming months we can put together a session on an updated session on logic apps.
Kind of logic apps are the state of the nation.
Yeah, kind of something like that.
I might be able to help with that that ISE stuff.
Yep.
Yeah,
so,
and I can put my hand off the general stuff. So we might do like a combined session then.
Yep. So once you guys once you get back from when you get back from Integrate in the US, so maybe July or August we can put together something like that.
Yeah. Cool.
Okay.
Sure.
Are there any other questions? If you I think there's the if you can just
there is one on the chat here. Can you explain again how to avoid duplicate trigger from event grid to the logic app?
Okay, so let me show you what I mean to say. So I'll just quickly reshare my screen.
Yep. You may need me to stop sharing. There you are. You got it.
Yep. So if you check this event grid result topic, what I'm saying is once we tag a logic app to this, what it sometimes does is if I disable, right now there are two instances of two different logic apps subscribing to different filters right now. So what I'm saying is if I go to any one of the logic apps and I say, I just disable it and probably enable it once again. And if we go to event grid, sometimes what it does is it registers one more event subscription here, which right now has not happened, but I have faced this issue wherein I disabled my logic app because it was firing infinitely once. So what I did was when I enabled it at a later point of time after re-enabling the logic app, what it did was it registered one more subscription here, and when I later tested my system, it started firing the logic app twice for one event. So that's what I've learned there. Probably it might be a fluke thing that I've observed, but I make it a habit to check it after I disable and re-enable my logic app. So I hope that makes some sense.
Question there, basically about, do you need to retrain the model with samples from real captured pictures in the solution? So is it worthwhile, say, like after you run the solution for a little while, to retrain it with some of those real live images?
Yep. Well, as I said, the development cycle for Azure Custom Vision Service is upload images, tag them, train the model, test it, and repeat. So it's kind of a circular process wherein we go on retraining the model by uploading many images, so that it comes to a stage where it becomes almost perfect in detecting objects in the images. So yes, I would say retraining should be done. It's not mandatory, but I would say it's a best practice to keep on retraining the model after a while. It's similar to what we can do with the language understanding intelligence service. We should keep retraining these projects so that they evolve with time and as and when we get newer and newer data. I hope that answers your question, Ahmed.
Yep, there was another question out there on the structured logging that that blog post that you did that you mentioned about for Paco.
Yep.
I'm just trying to put that on the screen now, so you should.
I put it. Yeah, I put the link that on the answer.
Okay, so that's good too. So we got the answer there, but that's also that, and that'll be in the recording for that structured logging.
Yep.
Are there any other questions? If not, I think we will call that a night, and the recording will be up shortly on the integrationdownunder.com website. And then if you have any questions, it's also on the YouTube channel, but it's a little bit easier to get to through the Integration Down Under website. So thank you, Mandar, and thanks everyone for attending.
Thank you, everyone.
Thank you. Thank you, everyone.
Good job, Mandar.